Okay, how's everyone doing? How's everyone going? Came this close to canceling class this morning. This close, yeah, this close. Should have done it, huh? Because I made it. I made it in time. All right. I wouldn't want you to not have class. That would, sure, you'd all be very depressed. You show up and no class. I mean, that's no good, right? Okay, today we're going to do 3-3. My plan is at the end of class to have another individual activity where you work some problems out. I think I'll give you a heads up on that now. And we're going to try and do that the rest of the way, just to kind of help you focus a little more on what's going on in here. And maybe it'll help, you get to a different place with your understanding. I will, yes. I didn't put the one, I did update your grades, but not the one from last class. Okay, this, we are going to jump ahead. All the way to 3.3, Future Annuities. 3.1 and 3.2 we already covered, and that was on the previous exam. So let me kind of, before we get into this, tell you a little bit about what the 3.1 and 3.2 was about. That was compound interest, simple interest. So 3.1 and 3.2, that was simple interest. And from that, we got two formulas. A equals P times 1 plus R over N raised to the NT. And the other one we got was the PERT, the shampoo formula. Right? Those were our two formulas. Now, the problem with these formulas, not the problem, but one thing that you need to notice is that with both of these formulas, we put money into the bank or we borrow money or something like that, right? One of the two situations. Let's go with the idea that we put money into the bank. We put money into the bank at a certain interest rate for a certain amount of time, and we don't touch it, right? It just sits there earning interest. But a lot of times, things don't work like that. In other words, you might put money in the bank every month. Or you might, if you're borrowing money, you might be making payments on that money every month. So we need a formula that's going to account for changes that occur on a regular basis. And that's where the idea of a future annuity comes in. And then the next section after this is called the present. This is called future annuity. The next section is called present annuity, present meaning now. All right? So let me define some things up here for you first. Before we begin, an annuity. So what is an annuity? It's just a sequence of equal periodic payments. That's what an annuity is. So an example of this would be you make monthly payments on your credit card. That is a sequence. Well, you may not make equal payments, but let's just say you do. Like every month I'm going to pay $50 on this credit card that I have. That would be an annuity, a sequence of equal periodic payments. Understand? Then the book goes in and tries to derive this formula, which I'm not going to do the derivation of this. I'm just going to write the formula for this. This is the formula for future value of an ordinary annuity. All right, so here's the formula. FV, I'll explain what everything means in a second. PMT times, and then we have a big fraction here. We have 1 plus I raised to the n minus 1 over I. there's the formula. I will not ask you to memorize this, okay? These two I know you have memorized by now, right? No. The shampoo one, maybe? All right, so let me describe everything that is in this formula. All right, so FV. FV stands for the future value. So what we're doing with this formula is we're trying to predict the value of something somewhere down the road, maybe 10 years from now, if we keep making payments on something or if we keep putting a certain amount of money into the bank. All right? So future value is FV. What do you think PMT is? By the way, PMT is all one value. It's not P times M times T. This is just payment, okay? It stands for the word payment. Don't look at it as three different variables. Pardon? Yeah, this is going to be our equal periodic payments. These are the equal periodic payments that we're going to make. Look, all this section, this entire section, this is it. This is the only thing we're doing in this section, this single formula. All right, there's no other formulas. This is the only one. Now, we are going to do a problem today where we actually combine this idea with the idea from 3.1, 3.2. But I'll get to that when we get to the example. All right, so that's payment I. Okay, this one can be a little confusing. This is the rate per period. That has to do with the interest rate, all right? So you know when you get a credit card or something and they say you have like an interest rate of 15%, and that's your annual percentage rate, their APR, APY, they talk about these things. Okay. They usually say annual percentage. That's the period, all right? So it's the rate per period, I. We'll do an example. And then N is the number of payments. Or if you want, you can say the periods. This would be your number of periods. And does that cover all the variables here? The future value, the payment, the rate per period, the number of periods, and 1 and I again. So this is it, right? This is all we need? Okay, so let's do an example. Let's see how this works. I'm going to have to write the actual problem on the board, so it's going to take me a while. And while I'm doing that, I'm going to write the formula down over here so we can refer to it. This is times, okay, so we've got 1 plus I to the n minus 1 over I. All right, so I'll be using that. And I guess I'll put it here. All right, first one. What is the value of an annuity? So quiet in here. Are y'all just paying attention?
I was just noticing how you looked at me.
Oh, yeah? At end of 20 years, if $2,000 is deposited each year at 8.5% compounded annually. Question. All right, so in this problem, we want to know what is the value of the annuity, right? At the end of a certain period of time. So we want to know the future value of this annuity. So do you understand what we're doing every year? We're putting $2,000 in the bank, putting $2,000 in the bank. We do that for 20 years, right? If you had no interest, right? If you weren't gaining any interest on that, how much would you have after 20 years? If you just put $2,000, let's say you go in your backyard and you bury $2,000 every year. Once a year you go out there and dig a hole and put $2,000 in there. How much would you have at the end of 20 years? $40,000, right? Just 20 times 2,000, you'd have $40,000. But if you put it into a bank where you're earning interest, let's see how much we would have, okay? So, let's see here. What is, if we list out all the variables, the future value is what we want to know, right? What's our payment? 2,000. Okay. And what is the interest rate per period? So we're doing it every year, right? We're depositing it each year, and the interest rate is compounded once a year, annually, right? So our interest rate per period, or our interest rate, per period should just be this, 8.5%. Converted to a decimal, though. So it would be what? 0.085. And then N is the number of periods, 20, because I'm doing it once a year, right? Once a year for 20 years. So this is going to be 20. So now all we do is just plug everything into this formula. So the future value will be the payment, 2,000, times, okay, I'm going to do 1 plus I. And I is what? 0.085, so that's 1.085, right? When I add the two together, 1.085 raised to the N, and N is 20. Then I subtract 1, and then I divide by what? 0.085. Okay, so I asked everyone to bring their calculators, and I know everybody did, that we don't even need to have a calculator quiz today. We should? Yeah. Now everyone wants one? Everyone brought one except me. Oh, there it is. I think this is the one I left the other day. Okay, here we go. So where are we going to start here? Where would you start if you were going to start calculating this? I mean, you can type this all in at one time, but you've got to be really good with this. You've got to understand where all the parentheses go. And so, I mean, I would take it step by step. This right here to the 20th. Let's do that. Okay, 1.085 raised to the 20th power. And I'm going to write this down in detail so that way you can make sure that you're getting each of these little things on your calculator. 1.085 raised to the 20th is 5.112046.125. Now, I went ahead and just used every single digit that my calculator gave me. I would not round this to 5.1, or else it's going to be off by a little bit too much. I would say minimum 4 to 5 decimal places. All right, then I still have to subtract 1, right? And then I still have to divide that by 0.085. So what should my next step be? Subtract the 1. Subtract the 1. So we go 2,000, and then we do, this will be 4.112046.125 over 0.085. Now what? Divide. Let's do the division. So when I divide that by 0.085, I get 48.37701,323. Again, 4 to 5 decimal places, you're okay. And now just multiply this times 2,000, and we're there. Oh, wow. Okay. So how much would we have? 96,000 $754 and 2 or 3 cents. Close enough, right? So are you better off burying the money in your backyard every year, or are you better off putting it into an account where you're earning interest? You want to earn interest, right? Now, 8.5%, that's pretty high. It's going to be hard to find something like that. Now, the stock market, you can make that much in the stock market, but there's more risk. You can also lose money in the stock market. So, do you understand? All right, let's try a different problem. I'm sure you like this more than logarithms, right? Yeah. Yes, okay. Just, let's see, trying to think of let's do a quick comparison. What if you actually had, remember I said if you buried $2,000 in your backyard every year for 20 years, you'd have $40,000, right? Let's just say that you have $40,000 right now, and you put it in the bank at 8.5% and just let it sit there for 20 years. Do you think you're going to have more than we just had, or less? Do you understand the question? Scenario 1, I put $2,000 in the bank every year for 20 years at 8.5%. We know that if we do that, we're going to get $96,000 at the end, right? But if you had $40,000 right now and you just threw that into the bank one time, throw it in there, and don't touch it at all for 20 years, do you think you'll have more money?
Yes.
Probably. Let's see. How could we figure that out? We could use the PERT. Let's assume it's compounded continuously. It's 218,000? Okay, so you've already done it. So if you put 40 grand in right now into the bank at 8.5% for 20 years, right? Then we're trusting this calculation. A is PERT. What'd you get? 218,000. 957-ish, close enough, okay? Why so much more money? Because it started at 40,000, right? And your other money, it started out at 2,000, right? And then the next year it was only up to 4,000 with a little more interest on it. And then the next 6,000 with some interest on it, so it starts growing. It's growing as you put money in, right? But you're starting at basically nothing and building up. Here, if you put 40,000 in right off the bat, you're getting a lot of interest off of that big chunk of money. So it's growing, and it grows faster. Understand? Okay. All right, let's try a different example. A company needs to replace an $800,000 machine in 5 years. Okay, so you've got this company, let's say you're building cars, right? You've got this one machine that when the cars go through, it welds all the body, like the frame of the car together, right? This really complicated welding machine, right? $800,000 piece of equipment. You're gonna have to replace it in 5 years because it wears down, and it breaks, and you eventually have to replace it completely, all right? Now, you don't want to have to just, at the end of 5 years, just cough up $800,000. So you're gonna start actually saving for this purchase that you're gonna have to make in 5 years, right? So here's how it goes. To have this money ready in 5 years, a, quote, sinking fund, this is what we call these, a sinking fund is created. Now, that means that a sinking fund, there's a definition for what a sinking fund is. It's basically money that you're saving up that's going to be spent, okay? It's going to be used for something, so it's already spent. It's a fund that's going to, when it reaches its maturity point at 5 years, it's gone, right? Because you're going to use it right away. You plan to make equal monthly payments into an account at 6.6% compounded monthly. So every month we're going to pay into this account. We're going to be earning interest on this account, 6.6%. And that 6.6% is compounded monthly. Notice that the monthlies match. In the previous problem, we were making annual payments and the interest was compounded annually, right? All right. So what do you think the question is going to be here? How much should your payment be, right? How much is your payment going to be so that this actually has the money at the end? Any guesses? 5 years, $800,000? What would 800,000 divided by 5 be? 800,000 divided by, oops, that's not what I meant to do. 160,000, that's how much we need to put in every year, right? And if we divide that by 12, that would be about 13,333. That's how much we would have to put in every month, digging a hole in our backyard, putting $13,333 in there every month, and in 5 years we would have the $800,000 ready to go, right? But our money's not working for us that way. It's better if we put it into an account that earns interest and then at the end of that pull the money out. Then our monthly payments don't need to be that much, right? They need to be a little bit lower. But how much lower? Let's see how much it'll be, right? Okay, so we're going to set up the same formula. Let's see, how far off am I? Okay, I'm all the way over here. So let's set up our formula. Let's keep in mind that 13,333. That's how much the backyard bandit would be. Backyard bandits. I'll tell you all a story, but I have to turn my mic off. Okay. No. That's kind of, yeah. Okay, what are we doing? This formula, right? What do we know? Let's write down all the things that we need to do this. Payment I, and N, right? Those are the things we need. So do we know future value? This time we do, right? This time we know that this needs to be 800,000. Do we know the payment? No, that's what we're looking for. Do we know I? This is the part that I guess can get tricky. All right. So, what was the interest rate? Did I write that down there? Right. Okay. 6.6%. Right. And converted to a decimal, that would be 0.066. Now that's what you would think it would be, right? That's the rate, that's the I that you would have if your interest rate, or if your interest was compounded annually, that's what you would have, all right? But go back, when I wrote I on the board, what did I write? I said I was interest rate per period, right? Per period. So how many periods are we having annually here? 12. Divide it by 12. Divide it by 12. Now, what is N? The number of payments. How many payments are we going to make? 12 payments every year for 5 years. 12 times 5. Which is 60. Now, let's go ahead and get this 0.66 divided by 12. 0.066 divided by 12. 0.0055. You see how this problem is a little different because first problem, everything was annually. So if it's annually, this is a 1, right? And this is a 1. These two are 1s because it's annually, one time. If you change that, if you're changing 5 years or you're doing it monthly, then those numbers can change. With me? All right, so now let's plug everything into the formula. We have future value, which is 800,000, equals payment, we'll just leave it PMT, and then 1 plus I. What's 1 plus I? 1.0055 to the 60th power, right? Minus 1 over 0.0055. All right, let's calculate. You're going to do the 1.0055 raised to the 60th, right? So do that first. And then you will have 80,000 or 800,000 equals payment times, I got 1.3897110003 minus 1 over 0.0055. So then 800,000 equals payment times, I'm going to do all of this at one time. I'm going to do that minus 1, divide by that. Divide by 0.0055. 70.85, something like that. So 800,000 equals payment times 70.85654,594, something like that. Okay. We're trying to solve for payment, aren't we? Right? So I'm going to divide this side of the equation by 70.856545594 and divide this side by the same thing, 70.856, blah, 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 blah. So go ahead and do that. And you should get about how much? 11,290? 42 I'm getting, but that's your payment. So remember, how much was it? 13,300? That's how much if we buried it in the backyard. But if we do this using this sinking fund, saving for later, then we'll only have to put $11,290.42 in there. If you're not a backyard bandit, yes. All right. That's good? Okay. Let's do another one. I think this is going to be our last example. And there's only 3 examples in the book, so I'm going to do those 3 examples, and then I'm going to give you 3 problems to do yourselves. And when you're done, we'll call it a day. All right? So, all right, let's go and put in, let me write the problem for the next one here. I think the only trouble that you're probably going to have in this is figuring out the I and the N. Those can be a little bit confusing. So maybe with this 3rd example, we'll clarify it. All right, we have, oh, I just erased the formula. Good job, good job. Jane deposits $2,000 annually into an IRA. An IRA is just like an investment account that earns interest for you. At 6.85% compounded annually. After 10 years, she cashes out the IRA tax-free, which means when she goes to get her money, she doesn't have to pay taxes on it, because that would change things in the problem. Okay, she cashes this out tax-free and reinvests hold on a second. And reinvests into a simple interest account at same rate compounded continuously for 15 more years. How much does Jane have at the end of this? All right, so let's make sure we understand the problem. She's going to be putting in $2,000 a year, every year, into an account that compounds the interest annually. And after 10 years, she's going to take that money out. She's going to put it into a different account that has the same interest rate compounded continuously, and do that for 15 years. Yes?
So you have to sell first the first one, then.
That's right. That's right. So she's basically, when she's in the Roth IRA, there's a little more risk in there in the Roth IRA, all right? Because that money, when you loan money out to people, they're taking, remember we talked about banks, they take your money and they do something with it, lend it to other people. There's a possibility that those people they lend it to can default or lose the money or something like that. So there's more risk when you put your money into an IRA than there would be if you just put it into a simple interest account that's federally insured. It would have to be federally insured, of course. If it's not federally insured, then you may as well bury your money in your backyard. So the first 10 years, she's doing an annuity, right? And then the last 15 years, she's just leaving the money in there. She's not touching it, right? Do you all understand that? The last 15 years, she's not putting $2,000 in anymore. So for only 10 years, she's going to do $2,000 a year. All right, so let's break this down. Let's look at the first 10 years. So for the first 10 years, she's going to be using the future annuity formula, right? To figure out how much she has. So the future value is what we want to know. The payment, how much is the payment that she's going to be making? $2,000. What is I and what is N here? .0685. Because it's annually, right? So we don't have to, because it's annually, we don't have to divide by anything. Had that been monthly, that would change, right? That would divide by 12. All right, how about payments? Number of payments, 10, right? She's only doing one per year for 10 years. So 10, yeah, 10 years. So just 10. So let's go ahead and calculate the future value. The future value will be 2,000. Don't know why I did that. Times. I don't want anybody trying to bring back the backyard bandits now. Okay? These days you're going to be shot.
Did you do that? Did you knock ditch?
The what? Huh?
Did you ever go to pools yourself?
Pools? Oh yeah, you had to. You had to. It was a rule. Bit by dog? No. Chased by dog? Yes. We got hurt more on the fences than anything else. The fences were the hardest part.
Stayed behind. Would you go back for this or
No. It was a race. It was actually a race. There was a reward at the other end. That's the part I leave out. Huh? We would only do it like once every weekend.
Did any of y'all ever get caught?
No one got caught.
Oh, okay.
I mean, we had people yell at us and stuff, but yeah. But I'm saying these days, you're not gonna. No one's. You're gonna lose a couple of people there, probably. It'll be on the news. All right, 2,000, and then we have here 1 plus I, right? Which I can do that all at one time. I may not be able to post this video later. Minus 1 over I, which is 0.0685, because I'm thinking that's illegal. I don't know. Yeah? It's definitely trespassing. Well, I don't know. Is it trespassing? If they don't have a trespassing sign? It's a long time ago,
I mean, can you still get in trouble for it?
Yeah, statute of limitation. We didn't hurt anybody. Those pools would be cold, man. Those pools are cold. Okay, let's do this. 1.0685 raised to the 10th. So I'm going to try and do all this calculation and just give you the answer and see if you can come up with that yourself. Anybody want to share what they got?
27,430.
Okay, good. That's right. Future value is about $27,437 and 89 cents or so. Again, if you're off by a couple of dollars or something, that's okay. If you're off by like $400, there's a problem in your calculation. $27,437. All right. So that's the first 10 years. Now she takes that money, right? She cashes it out. She goes to a bank. She deposits that money into a bank that happens to have the same interest rate, although that's not going to be very easy to find. She deposits that and she leaves it in there for 15 years. And the question is, how much is she going to have? So now what I need to do is, and it's that interest is compounded how? Continuously, which tells me I need to use the PERT formula. So now I'm going to be using A equals P times E to the RT. Now I know that the P, right, is the amount that she's going to put in, which is the amount that she had at the end of 10 years. So our P in this problem is $27,437.89. Then E to the R. R is our interest rate, which was 0.06, I forgot, 85, yeah? And then times time, how long is she leaving it in there for? 15 years. And you've done this calculation a few times now, so let's go ahead and I'll just get the answer here for you. When you do this part, you should get, well, I'll just write it down here, 27,437.89. Then it's going to be times 2.7940711916. So I multiply those. I'm getting somewhere around 76,663.44. Anyone else get that? Yep. Okay, there we go. How much did she put in total? 20,000, right? She put 20,000 in. 10 years, 2,000 a year, 20,000. She has 76,000 in the bank now. But it's also, 25 years later, so, it's a quarter of a lifetime. She's more than almost quadrupled her money, but it's taken her a quarter of her life to do it, right? Almost.
So you said do the E first? Or figure that out?
Yeah, you should figure out this first, and when you do this part, you should get this. And then you do the multiplication. Okay. Let's see here. You ready for your problems? You'll have 30 minutes. And, I really want y'all to work together, but the problems that we seem to be having in here are problems with test taking and anxiety and being on your own and not having anything but yourself. So I want us to practice that a little bit more. So I'll ask you again to kind of spread out a little bit, and you can use your notes, all right? Use a book if you want, but please work alone. If you have questions, raise your hand. And yeah, on a separate sheet of paper that you will turn in. Put your name on it, put today's date. I will include the formula on the board here. All right. First one. What is value of annuity at end of 10 years if $1,000 is deposited every 6 months into an account at 8% compounded semi-annually. Do you know what semi-annually means? Twice a year. Twice a year. It's the first one. Second one. City needs to pay for new building in 10 years. Sinking fund is created with payments made every 3 months at 5.4% compounded quarterly. What will the payment be? If you do it every 3 months, how many times is that per year? 4 times a year? Okay. Quarterly, if it's compounded quarterly, that's done how many times per year? 4. Okay, just pointing these things out. All right, third and last one. Jack deposits $500 monthly into IRA at 6% compounded weekly. Oh, I didn't put the building cost. Oops. Sorry. New building. It's $5 million. It's a building. Thank you for pointing that out. So Jack deposits 500 monthly into an IRA at 600 weekly. He does this for 15 years. Takes money out. Puts into simple interest. Account at 3% continuously for 15 years. How much money does he have? Okay. Let's see how you do with those. And before you come ask me any questions or raise your hand, let me work these out so I can get the answers for you. Is that yours? Go ahead, have it. I'll use my own. Do y'all feel like maybe if y'all paired up it would be a little better? Yes? Okay, if you pair up, I want y'all to actually help each other and learn. Don't just like copy off your neighbor and be like, I have no idea what I'm doing. The whole point of this is so that you understand what to do, all right? So I don't mind you talking through with someone, but make sure you know how to do it. Excuse me. Thank you.